or ECE of ion deposited. Faraday's laws of first law of electrolysis. Michael Faraday reported that quantity of elements separated by passing an electric current through a molten or dissolved salt is proportional to the quantity of electric charge passed through the circuit. This became the basis of first law of electrolysis. M is equal to K into Q. Now what is Faraday's second law? It states that when the same quantity of electricity is passed through different electrolytes, when the same quantity of electricity is passed through different electrolytes, the mass of different ions liberated at electrodes are directly proportional to their chemical equivalents. What is Faraday's second law? When the same quantity of electricity is passed through different electrolytes, the mass of different ions deposited are directly proportional to their chemical equivalents or equivalent weights. So W is directly proportional to E. So W1 over W2 is equal to E1 over E2, or Z1 IT, put the values of W, W is equal to ZIT. So Z1 IT over Z2 IT or Z1 over Z2 is equal to E1 over E2. E is directly proportional to Z, or E is equal to FZ, or E is equal to 96500 into Z. Second law of electrolysis. Faraday also discovered that the mass of resulting separated elements is directly proportional to the atomic masses of the elements when appropriate integral divisor is applied. This provided strong evidence that discrete particles of matter exist as part of the atoms of element. Faraday's law for gaseous electrolytic products. For gases, we use V equal to IT. V E over 96500, where V is the volume of gas evolved at STP, at an electrode, where VE equal to equivalent volume equal to volume of gas evolved at an electrode at STP by 1 Faraday charge. Electrolysis of sodium chloride solution uses battery to bring about chemical changes, that is decomposition. When molten sodium chloride subjected to electrolysis, sodium ions migrate. If you see this picture, the sodium ions migrate to cathode and chloride ions they migrate to anode. At anode, chloride ions they migrate to anode and sodium ions migrate to cathode. So the overall reaction is Na plus Cl, NaCl. The chlorine ions are now attracted to positive electrode, that is anode, and undergoes oxidation. Sodium ions are attracted to negative electrode, that is cathode, and undergoes reduction. Sodium ions they are attracted to negative and cathode and it undergoes reduction. This process is used in industry to form sodium metal with chlorine as a byproduct. The production of sodium takes place in industry in a special electrolytic cell called Downs cell. Numerical problems of Faraday's first law of electrolysis. First example is a current of 4 amperes on passing through a solution of silver nitrate for 25 minutes deposited 6.66 gram of silver. Calculate the electrochemical equivalent of silver. Calculate the electrochemical equivalent of silver. Now what is the solution? Here W is equal to 6.66 gram and I is equal to 4 ampere. T is equal to 25 minutes. So 25 into 60 is equal to 1500 seconds. Now we know that W is equal to Z into IT. This is the Faraday's first law. Now put the values. So Z is equal to W over I into T. This is equal to 6.66 over 4 into 1500 is equal to 0.001. So this is the value of electrochemical equivalent of silver. So ECE of silver is 0.0011. Second problem. How long will it take to deposit 0.3 gram of copper when a current of 0.5 ampere is passed through copper sulfate solution. ECE of copper is 0.00032. Solution is W is equal to 0.3 gram, I is equal to 0.5 ampere. Now what is T? Z is equal to 0.0032. Now W is equal to Z into I into T. Put the values. So T is equal to W over I into Z. This is equal to 0.3 over 0.5 into 0.00032, and this is equal to 1875 seconds. So the time taken to deposit copper is 1875 seconds. Another example, calculate the weight of copper deposited when a current of 0.5 ampere is passed for 20 minutes through a solution of copper sulfate. ECE of copper is 0.00032. Now what is the solution? Calculate W. Here I current is equal to 0.5 ampere. T is equal to 20 into 60 is equal to 1200 seconds. Z is equal to, that is ECE of copper is 0.00032. Again W is equal to Z into I into T. W is equal to 0.00032 into 0.5 into 1200. This is equal to 0.192 gram. Hence, weight of copper deposited is 0.192 grams. One more example, when weight of copper will be deposited, what weight of copper will be deposited when 2 Faradays of electricity is passed through a cupric salt dissolved in water. Here the atomic weight of copper is 63.5. So today we have discussed laws of electrolysis, electrochemistry and process of electrolysis and some numerical problems. That's all. Okay, thank you.